Hi guys, today we're going to look at day 2, reflecting functions. We're still going to be using Hicks and Boy today, so I want to start by actually writing out again what that means. H is horizontal. I means inside parentheses, and X means X's are affected. V for vertical. O for outside parentheses, and Y for Y's are affected. I think that Hicks and Boy is going to become really handy for you today because these reflections may not be what they typically would make you think. So we've got this parabola, f of x equals x squared minus 6x plus 5, shown on the grid below. It says consider the function g of x equals negative f of x. Determine a formula for, this should say g of x, change that for me, for g of x and graph it on the grid below. So we know that g of x is equal to negative f of x, where f of x is x squared minus 6x plus 5. So notice that I put a big negative outside of pair of parentheses because we're negating the entire function based on the definition of g of x. So when that big negative is on the outside, it does have to be distributed to the inside. So we have g of x equals negative x squared plus 6x minus 5. Then it says to graph it. So we're going to do that using our graphing calculator. If you don't have one, that's okay. You can follow along with me. I'm going to choose to graph this one in purple. And in order to, just to help me see a different color on here, because we are going to have 3 graphs in total on this one grid. Okay, so we're going to start graphing with 0, negative 5. Then we have 1, 0, 2, positive 3, 3, positive 4, 4, positive 3, 5, 0, and then 6, negative 5. We're going to connect them and call it g of x. So this next question says, how was the graph of f transformed to produce the graph of g? So you can see that this flipped, the graph flipped upside down, and a flip is called a reflection. So it's a reflection over, now we got to decide what we reflected over. So it looks like the x-axis. And in order to do this, we negate the y's. Keep the x's and negate the y's. Negating the y's was where we negated the entire function. Because remember, when we have g of x is equal to y. Same with f of x is equal to y. So what this is really saying is that we want g of x equals negative y. Because f of x is equal to y. So again, reflection over x-axis means to negate the y's. Negate the opposite value. So let's take a look at the next one. It says now consider the function h of x equals f of negative x. So we're going to write a new equation, then we're going to use our calculator to graph it. This time the negative is on the inside of parentheses, which means that we're not putting one big pair of parentheses here, we're putting several pairs of parentheses every time we see an x. And every time we see an x, we're going to change it to a negative x. So we have parentheses, negative x, parentheses squared. Then a minus 6, parentheses, negative x. And then just a regular plus 5. Now if I were to ask you what, say, negative 4 squared is, hopefully you would tell me that it's positive 16. And if I asked you what negative 8 squared is, you would tell me that it's positive 64. So if I ask you what negative x squared is, you would tell me that it's positive x squared. Right? Yes. So here, even if you negate a value and then you square it, it always becomes positive. So we're going to rewrite this as x squared. Then next we have negative 6 and then times negative x. That turns into a positive 6x. And then we just carry down plus 5. So now I'm going to use my graphing calculator to plot this on our graph below. Again, if you don't have one, that's okay. You can follow along with me. So we're going to start with negative 6, positive 5. Then we have negative 4. Nope, just kidding. I skipped one. Sorry. Negative 5, 0. Then negative 4, negative 3. Negative 3, negative 4. Negative 2, negative 3. Negative 1, 0. And 0, 5. And this one is h of x. So when we talk about part D, where it says how was the graph of f, the original, transformed to produce the graph of h, the new one, the newest one, we took this, oops, I didn't mean to erase. We took this original graph here in black, well, with my red pen over it, and we moved it onto this other one in blue here. So as we do that, again, it's being flipped. In other words, a reflection over, this time, the y-axis. So when we do it this time, we're going to keep y, but we negate the x's. So I want to relate this back to Hicks and Voy, because I said it's going to be helpful here, and I haven't yet showed you how it would be helpful. If we go back to part A, it says that we have g of x equals negative f of x. That's an outside negative, so that means Voy, meaning the y's are being changed. So if I change the y's, say I start with positive y's, and then I bring them down here to make them negative y's, that's a reflection over the x-axis, which is exactly what we said for part B. Then if we take a look at this negative on the inside, that's a Hicks problem. Hicks changes the y's, or I'm sorry, not the y's, the x's. So if I start with positive x's and I move them to negative x's, that there is a reflection over the y-axis, just as we said for part D. Okay, Hicks and Voy is very helpful when we think about reflections. Let's flip the page so we can actually see how to do them and how to summarize them first. So vertical reflection is a flip over the x-axis. And I want you to write yourself a note that this means to negate y's. That's because this was Voy, vertical, Voy. The next one, horizontal, oh, I'm sorry, I skipped the part. It occurs when f of x becomes negative f of x. So the next part, horizontal, flip over the y-axis. In this case, we negate x's. And occurs when f of x becomes f of negative x. And again, this is Hicks, horizontal, inside, change the x's. So let's talk about what's happening here in these transformations. I know it says practice, but I'm kind of going to guide you through them a little bit. We have an inside negative, so that means Hicks. If I have to change the x's, I'm going to start with positive x's and make them to negative x's, which means that we are reflecting over the y-axis. Notice I just used this little lowercase r. That means reflection. You're welcome to use it too. You used it last year in geometry most likely, so you can carry that through for the rest of your math career. Woohoo! All right, the next one, I see a negative on the outside, so that's forced me to use Voy. Void changes the y's, so going from positive y's down to negative y's. That there is flipping over the x-axis, so it's a reflection over the x-axis. Part C has multiple things to it. I have a -3 on the inside. That's a Hicks problem. Left, right, up, down, you got to decide. Hopefully you chose right 3. And then I have a negative on the outside. That's a void problem. I like drawing this little graph because the visual is just so effective in figuring out what is actually happening. So void means change y's, positives to negatives. So that there is the flip or reflection over the x-axis. For the next one, I have a negative on the inside. That's Hicks. If you negate x, what's that doing? Reflecting over the y-axis. And again, here's that visual. Take positive x, make it negative x. You are flipping over the y-axis. Then we have this +6 on the outside. That's void. Decide, are you moving up, down, left, or right? Hopefully you said up 6. All right, we've got a practice problem or an example problem here where we are writing new equations after both a reflection in the x-axis and a reflection in the y-axis. So first we'll do the reflection over the x-axis, and then over here we'll do the reflection in the y-axis. So if we reflect over x, that means that we are doing what to the y's? Keeping or negating? Write yourself a little note. If we flip over x, we negate y's. And if we flip over the y-axis, we are doing what to the x's? Keeping or negating? If we reflect over y, we negate the x. So now we have to write new equations. So if we are negating y's, that means that we have negative g of x. Negate the entire thing. So negative, parentheses, 5x minus 7. Distribute that negative just as we did on the front page. So we have negative g of x equals negative 5x plus 7. And we're done. Well, with the first part. The next part says negate the x's. So instead of negative g of x, we have g of negative x. So 5 parentheses negative x minus 7. G of negative x equals 5 times negative x is negative 5x minus 7. All right, now we've got 2 practice problems, one here and one on the next page. Each of them, you have an equation, and then you are doing some certain reflection to it. You have to decide what variable, what letter are you negating? Are you negating x or are you negating y based on the reflection? If you draw yourself these little visuals, starting always with positive, positive, and then it says reflecting over the x-axis, figure out where would you draw if you're reflecting over the x-axis. Go ahead and try to answer the problem on your own. I'll do it independently here on the screen, and you can check in as you need to. Once you finish practice 1 and you check your answer, move on to practice number 2 on the next page. If you need more time, just pause the video, otherwise move on. Again, do this problem independently. I will be showing my work up here on the board. as you do yours on your paper. Again, if you need more time, pause it. Otherwise, move forward with me. We're going to skip example 3 and move on to example 4, where we're actually doing the reflections, and then we'll talk about what problems to do for your homework. So example 4 gives us this function, negative f of x, where f of x is already graphed, but we have to negate f of x, meaning that we're negating y's, so we are reflecting over the x-axis. Wow, my writing's really messy right now. Reflecting over the x-axis. And again, we could have figured this out by using voy. Voy changes the y's from positives to negatives, which means that we are reflecting over x. So I want you to actually kind of highlight the x-axis, and then we're going to do the reflection together. So I'm going to start in the bottom left where I see this point down here. And in order to do a reflection, what we do is count boxes. So I'm going to count to the x-axis, which is why we highlighted it. So I'm 1, 2, 3 away, which means that now I'm going to go 3 beyond it. We have to make it look like a mirror image, a reflection. So now I go 1, 2, 3, and this is where I'm going to plot my point. Okay, so now moving to the next point, which is right here. And I'm counting towards the x-axis, 1, 2, and now I count the same number beyond it, 1, 2. And there we go, plot the point. Now I move to my third point, right here. Count towards the x-axis, 1, 2, 3, 4, 5, and now count the same number beyond it, 1, 2, 3, 4, 5. Move to the next point, the vertex up here at the tippy top. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Plot the point. Do the same for each of your other points that you see. Once you have all of them, then you're going to connect them. As you can see, what we did was make a mirror image over the x-axis. If you need more time, just pause the video. Otherwise, move on with me for part B. In this case, we have f of negative x. So this is a Hicks problem where we have to negate x's, which means that it's a reflection over the y-axis. And again, that visual could be very helpful to you right now. Starting with positives, moving, negating the x's because it's Hicks, means that we are reflecting over the y-axis. So the process is the same here. Start with the furthest to the left or wherever you want to start, it doesn't matter. And this time, instead of counting towards the x-axis, we're going to count towards the y-axis. So if you want to highlight the y-axis, that might be helpful. So I'm going to start with this point on the far left. And I'm going to count towards the y-axis. 1, 2, 3, 4, 5. So now I count 5 beyond it and I'll plot the point. 1, 2, 3, 4, 5. Okay, I'm going to do the same thing with the next point, moving upwards on this parabola. So here on the middle left, count boxes, 1, 2, 3, 4. 1, 2, 3, 4. Plot the point. Do the same thing for every single point that you see. I don't like that they put that squiggly arrow there. It's in the way. Don't they realize that? And this was f of negative x. Again, if you need more time, just pause the video. Otherwise, flip to your homework so that we can circle problems together, please. All right, so let's look at the homework filling in the first part of the table together. Remember that you may want to think about Hicks and Voy. Try to fill it in on your own, and then I'll explain it in just a minute. Decide what axis are you reflecting over. So you can see that I really used Hicks and Voy here. I used the little visual. Inside parentheses means Hicks. Hicks changes x's, so I went from positive x's to negative x's, which means that we reflect over the y-axis. Then the next one, the negative's on the outside, and so that means Voy. Voy changes y's. Y's go from up to down, so that's a reflection over the x-axis. So now you guys are going to be doing numbers 2 and 3, as well as number 4. So all of the front page. Then let's flip it and look at the next page. Go ahead and try, 5 and 6. Skip 7. Do number 8. And then give number 10 a shot. So again, on the back side we have 5, 6, 8, and 10. Okay, remember, if you need to go back and rewind, that's fine. There's no shame in doing that. It just means that you need a little bit more practice or a quick refresher before you move on, and that's okay. That's why this video is here, so that you can go back whenever you need to. Otherwise, move on to your homework and then try your ticket out for me.